This is a LabVIEW Beginner Lesson Series. The focus is creating a heart rate monitor. Today's lesson is 1.1 and its focus will be on getting a reading with the MyDAQ. This lesson we will connect up the MyDAQ, we will set up the DAQ-MX loop and then get a reading with the MyDAQ. At the end of this lesson we should have a continuous reading from the MyDAQ. We can start by creating a new VI. We'll call it after lessons. If you haven't already, you need to plug in the MyDAQ. When you plug in the MyDAQ, this should appear. If this doesn't appear, I would go to an earlier lesson where I talk about what to install, drivers, etc., as you might not have the correct drivers installed. For now, we'll just continue. We'll just click it away as we already started the project we wanted to. Find the DAQ-MX VIs. First thing we'll do is to put the create channel VI. This is to reserve the resource, which is the MyDAQ, which we will need. Then we will configure the timing with this VI. I'll go into the details of each VI later. I'll just place all of them out now. And then after we've configured it, we want the readings to start. Then we want to actually get the readings. And when we're done reading, we want to stop the readings. And then at the end, we want to clear the resource so it's not reserved. So at the end of the application, anyone else can use it. A handy function when doing this is just to select this one and they will line up. Another handy thing you can do is hold Control. First press space without letting go of Control and then press W. And this will automatically wire up all of the boxes together if they have the same wire. If they don't, they will get an error, but then you can fix that. We'll start with the resource VI. Here we'll set the maximum and minimum voltage. We have a simple circuit that goes from 0 to 5 volts, so we can just set the lowest as 0 volt and the highest as 5 volt. So you have a task which you can create from the beginning, but we don't care about that. What we do is we want to select the physical channel. So we create a constant and then we choose the MyDAQ. We want an analog in, we want the analog in 0. So we'll select that. And that's it for this one. Now we'll start a task which reads the analog input 0 and configures it to read it from 0 to 5 volts. Next, we'll have the sampling clock. So we want to choose a sampling mode. Finite sample means it only collects a certain amount of samples before stopping. But what we do want is just continuous because we want it to read until we tell it to stop. And secondly, we want the rate and we want 1000. All these numbers can be confusing after a while. So a good practice is to always just have visible labels. Now we know that this is the rate. We will know that this is the minimum value and we will know that this is the maximum value. This is very nice when you come back to the project later and instead of just seeing a lot of numbers, you will see what they actually are. We can also take this one, physical channel. Next, we will start it. This doesn't need to be configured in any way. It just starts when it runs over this one. And then here, we have one channel and we want continuous sample. So what we do is with a single channel, multiple samples, and for ease, we'll just choose a double. You can choose a waveform, then you have the time put into it, but we don't need that for now. We can either create something here, but that will create an array, Or what we can do is to go to the front panel and we'll choose a waveform chart. Just because the chart stores the data in there so we can see it over a longer period of time without hassling anything with storing the data for now. And we have it here, so we'll just connect this one here, and that's it. And now we'll just move these a little bit. And what we want is actually this to run and read the data for as long as we want. We don't want it to just play, read, and then go here. So what we'll do is we'll add a while loop here. And then a stop. In any while loop, it's good practice to just add some timing here. So this will not affect the reading as it goes on its internal clock. So you have to worry about that for other stuff. But for now, this will only give out data once it's ready. And instead of asking it all the time, do you have the data? Do you have the data? We'll just ask every 200 milliseconds. We can close this one now. And then it stops. And then it lets go of the resource. We can then make an error indicator here, which will show us any errors. And save. And let's try it out. And now I'll have a flashlight going over it, and you'll see it reacts. So I have just a basic circuit. It's not ready to read the heart rate yet, but it's ready to just take up signals, and as you see, it gives us feedback. If you don't get this, and you don't get any error, you just get some noise, I would suggest that you check you have connected the circuit correctly and to the correct input. Remember, we are using the analog input 0, so double check that on your board. And we'll stop it, and that's lesson 1.1. We have a MyDAQ working, responding to input. In the next lesson, we'll focus on getting this a bit more pretty, compartmentalizing it so it's easier to use in a larger application.